Hey everyone, this video is to discuss conditional probability. What conditional probability is it contains a condition that may limit the sample space. Remember, the sample space is the list of all possible outcomes. So this has something that takes the sample space and makes it smaller, creates a subset, and that's why we call it conditional probability. That condition must be met. Your formula for this, you can see, is the probability of B, and then you have a bar A. And the way that we read this is the probability of event B given event A. So as you can see here, we can think of this bar as a fraction, and the probability of A is going to be your denominator. How this looks in a Venn diagram form. Probability of B given A is the probability of A intersect B. Remember, A intersect B is A and B over the probability of A. So I have circle A and circle B. The probability of A is what goes in my denominator. So that's the entire circle. So in this case, we almost forget about circle B. It's not really included here because I'm given A. So A is going to be my denominator. And then the probability of A and B is just the intersection part. So in this case, I'm not really even focused on this part of my Venn diagram. My condition here is that it has to be within the probability of A. That's why I only focus on the circle of A. So in this video, we're going to show just examples using two-way tables, and then we'll have another video showing some other examples. So remember, when we have our table, we want to go through and we want to total everything first. So 8 and 5 is 13. 6 and 7 is 13. We should get a total of 26. We're going to double check that with our rows as well. So 8 and 6 is 14. 5 and 7 is 12. Once again, adds to 26. The table shows the results of a class survey. Find the probability that they own a pet given that they are female. Given female means I don't care about males in this example. I'm only focused on the females. Well, how many total females do I have is 14, so that's going to be my denominator. That means I totally ignore the males. I don't care about males in this problem. Of those 14 females, how many own a pet? That would be the people who said yes. So that's my numerator, 8 over 14. I can simplify this down to 4 over 7. You can think about this using our formal formula that we're given, or what I tend to do when I do these examples is I cross out whatever's not important. So in this one, I'm only focusing on the females, which is why I eliminate the males. 14 is my new denominator. 8 is the females who said yes, they own a pet. Okay, second example, I'm going to go ahead and total. So 7 and 7 is 14. 6 and 8 is 14. Total of 28. Let's double check that happened. 7 plus 6 is 13. 7 plus 8 is 15. Once again, adds to 28. So the table shows the results of a class survey. Find the probability that they wash the dishes given that they are male. So males are who I'm focusing on this time. I don't care about females in this example. I'm only focusing on the males. How many total males do I have? 15 goes in the denominator. Of those 15, how many said yes, I wash the dishes? 7. which goes in the numerator. And then 7 over 15 can't reduce. So that's our final answer. Okay. And then our last example that we have here, we have typically you hear these called two-way tables, but what you'll notice is that you can see a lot of different numbers here. So I'm going to total up my recycled materials. To get 60.7. I'm going to total up my non-recycled materials to get 156.3. I'm going to add those together, 217. We're going to do each row as well, just to make sure we have the same total. Okay, so then once again, I'm going to total down the row. You should be following along and adding these together with me. And once again, we're going to get 217. So using the data in the table, find the probability that a sample of non-recycled waste was plastic. I give you a formula or the form that it's written, probability of plastic given non-recycled. The key idea here, find the probability that a sample of non-recycled waste. I'm telling you, I'm focusing only on the non-recycled waste. In this case, I don't care about anything that was recycled. I'm only focusing on the non-recycled, which means my denominator is going to be 156.3. Well, of that non-recycled, what was plastic is going to be this number, 20.4. Now, when probabilities are given to you in decimal form or in percent form, we typically don't leave them as fractions. So I'm going to go ahead and divide these. And that's going to give me 0.13 or 13%.